in our practice, we list all the components that are essential and optional during the conversion. You will see that 18 essential parts, you can see one by one, and also another 9 optional in terms of gearbox, CV shafts, axles, adapter plate, spline shaft, because different cars, the structural status is different. We have to be in this kind of preparation. EPS, EHPS. So the last corner is the HS code. That is to help for importation, for customs. Sometimes we need to retain the original gearbox. Sometimes we need to remove the original gearbox or transmission from the gasoline vehicle. We can see the pros of retain the original manual gearbox. So it has lower cost, easy to install, better climbing, retains original driving feel to keep the manual gearbox. But the challenge is there will be more customized work. We need to customize the spline shaft and adapter plate based on the original transmission structure. There has more maintenance, and of course there is some drivetrain loss. But it's good for pickups, for the off-road and heavy nose mountain roads with no budget, minor shifting hours. So this is the advantage and disadvantage of remaining the original manual gearbox. Meanwhile, if we remove the original gearbox, the advantage is has even simple structure, higher efficiency, less maintenance, better EV integration. The driving sense of smooth is good. So, but the challenge and the disadvantage is it has higher motor requirement in terms of the torque and RPM. There will be more chassis work customization, and there will be sometimes there will be gear ratio limits, because traditionally the fuel vehicle has many different gear ratios and stores. It is good for passenger cars, for fleets, and wines or logistics standardized project, smart platforms, and modern EV experience seekers. We list all this advantage and disadvantage of remaining or removing the original gearbox for your reference. Step 3, we need to design the electric powertrain to match the original performance. So the philosophy here is, we have to match or exceed the original peak power and torque of the combustion engine. So this engineering focuses on the seamless, familiar, and driving experience for use when delivering the energy efficiency and the environmental benefit, eliminating any compromise on performance. So we're talking about the match for the original, the motor power specification. So for example, the model we are going to choose is the output kilowatt would be 130 to match the original Toyota Hilux. The battery size, we have to calculate the total consumption of the battery to meet the range. Nowadays, the main cost still lies in the battery pack. So we need to check the battery size in terms of the range and also the space consideration. So this key takeaway is performance parity is non-negotiable. The powertrain is engineered to meet and exceed the user expectations for responsiveness, while the calculated battery capacity ensures the practical, efficient daily use without range anxiety. Nowadays the main challenge for the electric vehicle users are the range anxiety. So this is the battery, the motor, control, and the battery pack. We we choose from our practice, you will see this is a rated 70 kilowatt motor, and the peak power can be 100. Yeah, the controller system, we're talking about the efficiency and the range and the current it contains. The battery size, of course, mostly it is kind of customization. Here we have 360 wattage, 105 ampere hour, and also the 360 wattage, 210 ampere hour battery. Yeah, the purpose of the customization of the battery is to maintain the range that's necessary for the customer. Of course, sometimes this is subjected to the budget for the user. Yeah. Yeah. Here you will see the test. This is the test curve and diagram for the motor. You will see in different situation of application, the speed change, and also, yeah, in different torque it appears. I think you can review that. I will not go in detail. Here you will see the efficiency map. Yeah, from the two axes, you will see the speed and you will see the torque. It interacts. And we will, from this map, we will see where is you will see the most functional performance of the motor. Yeah, you will see from that. This is also the peak power supply characteristics curve. We can see, yeah, in terms of the efficiency of the motor and the torque, the equation and the relationship. Yeah, the relationship. We can see that after that. Because of the time limitation, I will not go in detail. So this is the motor. This is the motor characteristics. You will see we use permanent magnetic synchronous motor. This motor has the liquid cooling. By saying liquid cooling, it will be very good for the high temperature environmental. The continuous power is 50, and the peak power, is 100. So you can see the main characteristics of the motor that supports the performance for the conversion. So we have a wide range of motors, ranging from 10 kilowatt to 120 kilowatt for different applications. Yeah, so this is only one sample. Here you will see the vehicle powertrain torque calculation formula. So this is not the complete formula. Because there are a lot of calculation behind. I just list the main factors that affect the performance, the speed, the torque of the vehicle. You will see, suppose you want to develop the conversion from the fuel to electric. We need to consider these kind of factors: the loading, the full loading, the motor efficiency, the max speed, the drag coefficient, the wind wall area, the coefficient of rolling friction on road, the tire rolling radius, the real axle ratios. So we need to put all these kind of facts to be the calculation stage. Then we will put in the real practice to match that. So it's a little complicated. If you are interested, you can explore that from a website. I think you can get it. Based on this formula tables and afterwards the calculation one by one, we can get the real number of what is the necessary power of the motor and what is the required controller performance needed for the conversion for different models, such as sedans, pickups, logistic vehicles, as well as buses, for example.